Hello all, my name is Krish Naik and welcome to my YouTube channel. So guys, we are going to start a very new project which is called as audio or sound classification with the help of machine learning or deep learning. Now, this is very much important guys, because many of you had actually requested this yesterday when we are doing an interview live session, and whenever I'm coming live sessions, right, at that time you're telling about audio classification. Now what we are going to do is that we are going to develop this project completely from scratch. We'll train it with ANN, CNN and various deep learning models, and we'll also try to see the accuracy. Remember, these videos will be mostly divided into 4 parts or 3 parts mostly. First one is the EDA part, then we have the data pre-processing part, and then finally we'll try to create a model, and then we'll try to implement this entire thing. Okay. Again, before going ahead, remember guys, audio, it's not like audio is also a very difficult domain. You need to understand the basic domain knowledge of audio itself. Like how does an audio, whenever we talk, right? Like suppose if I'm talking, whenever there is a disturbance in the air, right, it creates some kind of sound. Now over here, suppose just imagine this is a stagnant air. Okay, no sound will come like that unless and until you don't disturb that specific part of the air itself, right? And usually audio is basically given in a different types of signals that we are going to see. Again, the main agenda will be is to implement the project, and I'll try to implement this project in such a way that later on, whichever project or whichever audio classification you want to do it, you'll be able to do it. So let's begin. Now, first of all, we will start with what will be the data set itself, right? Data set is pretty much important. So here is the data set, which is called as urban sound at 8K data set. So this data sets contains 8,732 labeled sound excerpts for 10 different classes. We have air conditioner, we have car horn, children playing, dog bark, drilling, engine, gunshot, jackhammer, siren and street music. One of the example, if I take and let's see one of the example over here, I have already downloaded this data set. In order to download it, I'll also try to show you how you should basically download it and all. So here you can see that this data set is already been downloaded. If I go and probably click on one of the audio, suppose if I go and just see this, I think some kind of sound is there. I think it is a bird, I guess. Okay. Otherwise, if I go and see someone, yeah, I think the same thing. Yeah, so you can see different noise that are coming. So if I go and see this one, yeah, something like a dog one, like a, yeah, dog barking sound is definitely there. So when you download, and again I'll tell you, like this all data sets will be labeled over here, and we really need to predict by using machine learning like what sound it is actually. We'll also try to fine tune the model and all. So first of all, for downloading the data set, just go over here, click on this download form. Okay, I've given the URL anyhow in the EDA part. So once you click over here, you have to fill this particular form. Once you fill this particular form, this data set is somewhere around 4 to 5 GB. It will get downloaded. Okay, so once you fill this form and just submit it, automatically the downloading will start. Okay. Now let's understand what all things we are actually going to do in this particular EDA part. EDA is nothing but exploratory data analysis. Like how does a sound wave look like, right? Because just understand, this is just like some kind of audio files itself. Now first of all, I really want to install some of the libraries before we go ahead. First of all, if I go and see, there is a library which is called a pip install librosa. So I hope everybody has heard about this particular library. Librosa is a library. Here you can see requirement already satisfied. Now if I go and search for librosa library, this actually helps us to really work well with the sound signals, probably the sound data set itself. You'll be able to read that particular signals. You'll be able to find out the sample rate. You'll be able to find out how many channels it is and many more things, right? So librosa is the library that we are going to use. Apart from that, there is also a library in SkyPy which will actually help us to read the wave signals. So usually all these audio files that you're seeing will be in the form of extension as .wave. So if I go and see the properties over here, you'll be having this extension called as .wave files. Okay, so we'll try to use 2 libraries. For right now, I've just installed librosa. Now what I'm going to do is that let me quickly say import matplotlib.pyplot as plt. Okay, so what I'm going to actually do is that I'm just going to display the signals of one of the files. So that is the reason why we are using this matplotlib. So here I'll say matplotlib inline, right? And I'm going to write each and every line of code in front of you so that you will be able to understand what all things we are doing in the EDA. Now let me do one thing. Let me quickly go and see one sound data sets probably. I'll just go to my audio. Now here you can see that, guys, this is my file, audio classification eda.ipynb. Inside this I have just copied one doc_bark outside the folder, and I'll just try to test this out, like how the signals of this particular file looks like. So if I play this, so this is the dog signal, right? The dog noise audio, right? So here what I'm going to do is that I'm just going to display this particular audio file in the form of signals, and let's see how it looks like. Okay, so first of all, what I'm going to do, I'm just going to write file name is equal to, I'll just use my file name. My file name is inside urban sound 8k. So let me just copy this, urban sound 8k. So this is my folder name, and inside this I'm going to use dog_bark. So here we have dog_bark. So this is my file name that I'm going to basically use. Now let me do one thing. I'll write plot.figure. I'll just try to plot this, and here I'm just going to show my figure size. Figure size, sorry, it should be fig size. Okay, fig size is nothing but it is equal to 12,4. I'm just taking 12,4, or I'll just say 14,5, just it looks pretty much bigger. Okay, and then what I'm going to do is that I'm also going to install one library. Now this library will actually help us to display some of the graphs in this particular manner of the sound waves, which is called as ipython.display as IPD. And then here I'm writing IPD, okay, IPD.audio, and here I'm just going to give my file name. Okay, so this audio is basically my function which will actually help us to load the audio that is in the form of wave file, right? So here it will be basically giving us, it creates an audio object. With this object is written by an input cell or passed to the display function just to see it. Okay, so once I execute it, I'm getting an error. Rate must be specified when data is a numpy or this one. Okay, so what I'm going to do over here is that when I'm calling this audio, right, what I'm going to do is that, so over here you can see that there is some kind of error which is saying with respect to the rate must be specified. Now if I go and check out this over here, you'll not be able to see it. There is one parameter called as rate, right? Now this parameter, if I go and see, it should be an integer, the sample rate of the raw data and all. Now what I'll do is that in order to get that information, I will now be using this librosa library which I had actually installed over here. So let me import this librosa. So what I'm going to do after this, I'll just write import librosa, and then I'm also going to import one more library which says as librosa.display. And remember, guys, these all are some pre-processing that we are actually going to do so that at least we'll be able to display our librosa, our sound wave, you know, the sound audio that we are going to listen. Now this librosa, I can actually use librosa.load. I can load this file name, and once I load this file name, sorry, it should be lib. This usually gives us two information. One is the data, and the other one is basically my sample rate. I'll discuss about this sample rate, what is data and all, and why it is important with respect to the sample rate and all. Just give me some time, and here you'll be able to understand it completely. Then I'll say librosa dot display. Okay, I'm going to display this in the form of a wave plot, and this wave plot will be having two parameters. One is the data, which I will be basically reading from this file name, and the second one is something called as sample rate. Now if I write this with respect to my sample_rate, this will be able to display it. Now once I execute it, now again I'm getting one error. Let's see what is that error. It says no such file or directory, urban sound 8k /doc_bark. Okay, let's see what is the problem. Okay, so probably I've not given the path right. Now let's see if I go and write dir. Okay, if I execute it, so here I'll be able to see urban sound 8k is there definitely. Now instead of writing this dog_bark, let's see whether this path is right or not. So urban sound 8k and I have dog_bark. This is fine, but here I have to give my extension as WAV. Okay. Now once I'll go and execute it again, and let's see. Yes, now you can see this entire signals properly. Now we are not getting any file, any error, because now this audio wanted some kind of sample rate. And just by displaying this wave plot, I will be able to find out some information regarding the sample rate. And this by default reads that particular sample rate. Now if I execute this, now here you can see that we will be able to hear the sound. Now this is right, like this is the signal that is basically saying about this specific dog, right? Now this is the information that I've got, and I'll just write over here as probably we have just checked an example of dog sound. Okay, dog sound, and probably we have got some kind of information here, right? Perfect. Okay, now let's see this sample rate and data. What does it basically say? So if I go and see my sample rate, if I go and execute it, okay, here you will be able to see that I'm getting a sample rate of 22050. Now what is this sample rate? Let's see. I'll just Google it. Sample rate in audio. What is the sample rate in audio? See guys, in audio, a sample rate defines how many times per second a sound is sampled. That every second how much sound is actually sampled. That is what this particular thing says. And usually the standard sample rate is 44.1 kilohertz, but here I am actually getting somewhere around 22 kilohertz. I think 22 kilohertz, right? So approximately 22 kilohertz. Now by default, when we are reading with the help of librosa, okay, when we are reading this information with the help of librosa, then what happens is that we are reading the signals with the sample rate of 22040. That basically means, in short, whenever through librosa, whenever we are reading the data set with respect to some specific audio, we are actually getting the sample rate of 22050. Now similarly, if I try to see, it is not only this particular way which we will be reading the audio, okay. There are different ways also. We can use SciPy library, but understand one thing over here, librosa will play a very important role, because understand in a audio, right? In a audio, there may be different sample rates also. Like sometime one of the audio, probably in that particular audio, if I talk about channels, there are two channels in a specific audio. One is called as stereo and one is called as mono, right? Mono, let me take an example. Suppose I have this particular headphone, right? In mono, what happens if I wear this headphone? Both the signals will be equally reaching to both my earbuds, right? Probably the ear part. Suppose I'm listening to a song, right? So that particular signal will get divided from here and it will be giving us the information equally, right? Whereas in the case of stereo, some of the different signal may come at the right hand side of my earplug, or the left hand side of my earplug. Like suppose there may be audio signals, right, which will give a bass sound over here. There will be a sound signal over here, like that. So that is the basic difference between a mono and a stereo that you need to understand. Now, if I try to read with librosa, what it does is that it will try to normalize the entire data set, and it will just give the data with respect to a single sample rate. Now let me take one example, guys. So in SciPy, there is, so if I write from SciPy, right, .io, import wave file as WAV. If I execute this, okay, and if I try to read this wave file, if I write WAV of file name, right, if I read this particular wave file, it also gives me two information. Suppose I'll just say you what all information it will give me. It will just say that I'll write wave sample underscore rate, comma SciPy underscore audio. So this will actually give me this two information. One is the sample rate and one is the data that I had actually written. So let me write it out as wave underscore audio. Okay. Now if I try to execute this, okay. Now if I go and see my wave sample rate, here you will be able to see that initially from this original file, you know, the wave sample rate is nothing but 11025. But in librosa, we got the sample rate as 22050. Right. Similarly, if I try to see some other audio files, whatever will be the actual sample rate, that will get displayed. You know, some may have be 44 kilohertz, some may be 11 kilohertz, 22 kilohertz and all, right? And that is what we have actually seen, right? Kilohertz, right? Now in this particular scenario, what librosa is actually doing is that librosa is bringing a mechanism. Probably it will just read any audio file and it will try to convert that into a sample rate of 22050. Not only this, guys, as I said that there are two channels. One is the mono channel and one is the other channel, which is basically related to two different voices, right? It will also try to convert those signals into a mono channel. Okay, it will not just keep two channels. So librosa is very, very helpful in this kind of activities. Again, I know, guys, this may be looking very, very new to you, but don't worry. This is the analysis we basically do. We need to have some amount of domain knowledge. I've been working on this particular project from past 1 month. I really want to show you the different things with respect to that, right? Now what I'm going to do quickly is that here we saw that the sample rate with respect to this and with respect to this is 11025. Okay, let's see about the wave audio. Now if I go and see my wave audio, here you will be able to see different values. So what are these values? Remember, let me just show you one very nice diagram with the epic pen. Okay, so here suppose what I'm going to do is that I'm just going to just a second. Okay, just give me a second, guys. Now let's go ahead and try to see a sound wave. Okay, suppose I want to see a sound wave example. Sound wave example. Now in this particular sound wave example, suppose if I see this diagram, guys, again the entire if I'm seeing it from the Google, so I obviously want to give the credits with respect to this. Now this is my example of a sound wave. Suppose I'm just taking it, guys, I'm not discussing much about it. Just imagine that this is a sound wave over here. This each and every signals can be represented by an integer, by integer values, okay, or by a floating point values, and that is what is basically representing this particular values. And remember, when I have the specific values, if I try to combine them, if I try to probably combine them, it will be showing this kind of signals only, right? Probably at this point of time, the value may be something like -257, then at a specific point of time it may be -510. But if I try to combine this all values, it will actually become a wave. Okay, it will actually become a wave. Now in this particular scenario, you will be able to see that if I'm seeing this at this specific point, it may be having a different value. At this specific point, it may be having a different value. So if I try to combine them, it is going to actually create a wave. So in short, any audio signals can be represented in this particular numerical value. Now if I see in terms of librosa, suppose if I go and see this data in librosa, right? So here you'll be able to see that, okay, I'm also getting some values. Now one important thing about these values, guys, with respect to SkyPy, whenever we use, this is not getting normalized. This wave signal values is not getting normalized. Whereas if I use librosa, this is definitely getting normalized between -1 to +1. This is the major advantage. See, librosa is a library which is now popularly and commonly used for audio signal processing, because it actually helps us to do two things. One is that it tries to converge the signals. It will actually make only one signal, that is the mono one. The second thing is that it can represent an audio signals with respect to a normalized pattern, between -1 to +1, so that a regular pattern is observed from all the audios itself, right? This is the second point. The third point is that it is also able to see the sample rate, and by default it converts the sample rate into 22 kilohertz, right? In the case of other things like wave file, we will not be able to see that. In wave file, sometime we may see 44 kilohertz, sometime we may see some different kilohertz itself. Now this is the basic thing that I really wanted to tell you about this particular thing, guys. Remember, these are my features. I'll try to convert now these audio signals into something else, so that we'll be able to use that in our deep learning models, and probably we'll be able to do it, right? Now this was the basic example, and that is the reason why we are using librosa. Okay, now let's go ahead. Now what I'm going to do is that I'm just going to say import pandas as PD, and I'll say, okay, this is my metadata. Remember, guys, we have been given in our data set, which is called as metadata also. Now inside this particular file, if you see urban sound 8K, Inside this metadata, you have an urban sound 8k.csv. I'll talk about this CSV data set also, what it is. So let me just read it, read underscore CSV. And here I'm just going to write it as urban sound 8k, and then urban sound 8k, then we have metadata, then we have urban sound 8k CSV. So if I go and write my metadata dot head, and if I go and see my first 10 records, what will be, you'll be able to see this all things, right? Now what all information are there? This information says that this particular file is basically present in which folder, okay, 5 folder. Suppose if I want to see this particular file, how I'll go? Suppose here is my file inside my audio. Now it says that, okay, let's explore the first file. The first file is basically present in folder 5 and the class ID is basically dog bark. So that basically means if I try to open my folder 5, let me just show my folder 5, and what is the file name? That is 100032. 10032. Let's see, go down. So this is nothing but a labeled data set where exactly the location is present, right? So that we'll be able to write one code and we'll be able to read this entire audio file. So here it is, and if I play this data set, so this is the dog data set, and obviously that is labeled in that specific way, which is called as doc_bar, and this all information is there. Okay, now first check that I really wanted to do over here is that I really wanted to find out how many values are actually present, whether it is a imbalanced data set or balanced data set. That I really want to check over here. So in order to do that, what I'll do is that I'll quickly go and use this class probably, and I'll just try to use a value underscore counts, right? So now what I'll write is that check for, just to check whether the data set is imbalanced. Okay, now in order to check it, what I'm going to do, I'm just going to use metadata, and here I'm just going to use the class, and probably I'll just use value underscore counts. If I go and see this, now you can see street music is basically present 1000. Siren is 929, car horn is 429 and 374. I think it is not a imbalanced data set. It has proper good amounts of, most of the categories are having good amount of data set itself. Okay, now this was the one thing that I really wanted to check. Let's see some other things, what all things we can check. Okay, this information is good enough. We know that the data set is not imbalanced itself. The next thing that we will do is that we will try to create a function, you know, wherein what we'll do is that, see guys, over here we saw this particular information, right? We got the wave sample rate or the wave audio, this representation and this representation, right? This is through librosa, this is through wave audio. Now what I'm going to do is that we are going to read all these particular files and probably create this presentation later on, and also we'll try to write that particular code, and that is a part of data pre-processing. Here we have just done an EDA, a simple EDA to understand that how does a sound signal look like, this kind of waves is there. What I'll go is that, see, I'll also take some examples. Probably I'll just take this examples. This was another dog, this is another dog. So what I'm going to do is that I'm just going to paste it over here. Okay, I'll just take this signal, and what I'm going to do over here is that I will just read this entire thing. You can also compare different signals and all. I am not sure what sound it is. I'm just going to place my file name over here. So let's see what is my file name. My file name here should be whatever file name I'm actually going to use over here, right? Fine. So here I'm just going to execute this and write wave, and let's see. Okay, this signal looks something like this. Now if I try to execute it, I think it is a normal sound, some children speaking, I guess. It's a simple normal sound. Yeah, many children speaking. So these are signals, and this is how the signal looks like. This is the values with respect to the time. The time basically says that how big the audio is, or somewhere around 4 seconds. That is the reason why we are seeing this. Like this, you can basically explore it. Now we have got this particular information also. Now in the data pre-processing and data splitting, what we'll do is that we'll try to read each and every signals, and we'll try to get some audio and sample rate with the help of librosa. That is what we are going to do. The reason why I'm doing this very simple, guys, because I want you all to download the dataset quickly and complete till the EDA part, and I will be coming up with the next video where probably we'll be doing the data pre-processing and we'll be selecting this particular dataset itself. So I hope you like this particular video. Please do subscribe to the channel, and yes, this is just a tutorial 1, guys. Tutorial 2 will again come just in some time, or probably in the next day itself. So I hope you like this video. I'll see you all in the next video. Have a great day. Thank you, one doll. Bye bye.